Dear students, today we'll be talking about a very important aspect of matter. Can matter change its state? Yes, matter can change its state. A solid can be changed into a liquid, and a liquid can be changed into a gas. These transformations or transitions can be brought about by two very important factors. One is temperature, and the other one is pressure. So let us study the effect of temperature on the interconversion of one state of matter to another. The phenomena by which one state of matter can change to another and then back to its original state is called as interconversion. How does temperature bring about this change? When a solid is heated, it changes into liquid. And when a liquid is heated, it changes into gas. The conversion of a solid into liquid is a phenomena which is known as fusion or melting. Similarly, on heating a liquid, when it changes into a gas, the process is known as vaporization. If these changes can be brought about by increasing temperature, the changes can be reversed by decreasing the temperature. So when a gas is cooled or when the temperature of the gas is brought down, it changes into a liquid. And when a liquid is cooled, it changes back into a solid. The whole process of interconversion can be best explained using the example of water. Water is found in all the three states of matter: solid, that is ice; liquid, as of water; and gaseous state, that is in the form of vapor. What happens when a solid is heated? On heating the particles of a solid, the particles acquire kinetic energy and they start moving rapidly. The interparticulate gaps between these particles increases, and in this condition the matter fulfills the condition which is similar to that of arrangement of particles of a liquid. This is known as melting or fusion of a solid into a liquid. In a similar way, on heating the particles of a liquid, the particles acquire kinetic energy and start moving rapidly. Because of increase of temperature and increase in kinetic energy, the interparticulate gaps between the particles of a liquid also start increasing. The force of attraction between the particles of the liquid starts decreasing, and the configuration of liquid at this stage becomes similar to that of gases. This is the condition when liquids change into gases. The temperature at which a solid changes into a liquid at normal atmospheric pressure is known as its melting point. The melting point of ice is 0 degrees Celsius or 273 kelvins. Celsius and kelvins are two units for the measurement of temperature. Kelvin being the SI unit of temperature. Let us try to determine the melting point of ice. What will we need? A thermometer, a Celsius scale thermometer, a glass rod, an iron stand, a wire gauze, a beaker, a tripod stand, and ice cubes prepared from distilled water. Fill the beaker with dry crushed ice. Suspend the Celsius thermometer from the clamp stand such that the bulb of the thermometer is completely surrounded by ice. Start heating the beaker filled with ice. Read the thermometer readings after every 1 minute till ice melts. We will see that after some time, the reading of the thermometer becomes stationary for approximately around 2 minutes. Let us note these readings in the observation table. What do we observe? We observe that the melting point of ice is 0 degrees Celsius. And once the melting of ice starts, the temperature remains constant for some time. Why does the temperature remain constant for some time? The temperature remains constant because the heat that is being supplied is being stored in water as latent heat. Latent heat is also known as hidden heat. It can be defined as the energy absorbed or released by a substance during a change in its physical state that occurs without changing its temperature. The latent heat associated with melting of a solid is known as latent heat of fusion. The process of conversion of a liquid into a gas is known as vaporization or boiling. When a liquid is heated, the particles start moving faster, and at a particular temperature, the liquid changes into a gas. The process being known as vaporization or boiling. The boiling point of water is 100 degrees Celsius or 373 kelvins. Let us try to determine the boiling point of water. What we need is a Celsius scale thermometer, an iron stand, a beaker, a tripod stand, boiling tube, a Bunsen burner, wire gauze, beakers, etc. Pour 25 to 30 milliliters of water in a boiling tube and add few pumic stones to it. Clamp the boiling tube on the iron stand with a two-holed cork. In one hole, fix the thermometer, and in the other one, fix a delivery tube. Place the thermometer above water in the flask as shown in the figure and record the temperature. Read the thermometer and record your observations after an interval of a minute. So, what do we observe? We observe that the boiling point of water is 100 degrees Celsius. And once the boiling point is attained, the temperature reading on the thermometer does not change for some time. Why does this happen? This happens because the heat being provided is stored in water as latent heat of vaporization. Latent heat of vaporization refers to the amount of heat energy needed during the phase of conversion from liquid to gases. For example, when we are heating water and it starts boiling, the temperature remains at 100 degrees Celsius until the last drop evaporates because all the heat that is being added to the liquid is being absorbed as latent heat of vaporization and is carried away by the escaping vapor molecules. Do solids always change from solids to liquids and then to gases? No. There are certain solids which change their state directly from solid to gases and vice versa. Such solids or substances are known as sublime substances, and the process of conversion of a solid state directly to a gas and a gas directly to solid is known as sublimation. For example, camphor or ammonium chloride changes directly from solids into vapors. Ever wondered what happened to the naphthalene balls that your mother always puts in the woolen clothes? Every time we open these clothes, a faint smell is there, but we can never find those balls. Are they also sublime? Let us study the effect of pressure on gases. In general condition, the particles of gas are far from each other. They move independently and rapidly in all directions. The interparticulate space between the particles is maximum and the force of attraction between particles is negligible. It is because of these characters that gases possess maximum compressibility. So when pressure is applied on a gas, the particles come closer to each other. When particles come close to each other, they start attracting each other and the interparticulate spaces between the particles starts decreasing. On application of high pressure on gases, a lot of heat is evolved, which can be used by particles of the gas for movement. So, while applying high pressure to compress the gas, the temperature is kept low to overcome the heat release. As the particles of the gas come closer, they lose kinetic energy and finally get closely packed at a high pressure. At this stage, they get bonded with each other and turn into liquids. This process is known as liquefaction of the gas. The best examples of liquefaction of gas is the petroleum gas, which can be compressed to a small volume. At high pressure, it turns into liquid and can be packed into cylinders. Commonly used LPG cylinders or the liquefied petroleum gas cylinders, which are used in our households for cooking, is an example of gases being liquefied at high pressure. Can gases be changed into solids also? Yes, gases can be changed into solids also. Carbon dioxide gas can be changed into a solid at high pressure. Solidified carbon dioxide gas is also known as dry ice or card ice. It is used for the storage of food substances. So, let us sum up whatever we have studied in this PPT. We know that matter exists in three states: solid, liquid, and gas. The states of matter are interconvertible. The state of matter can be changed by changing temperature or pressure. So, conversion of a solid to a liquid by increasing temperature is known as fusion. On decreasing temperature, the liquid can be changed back to a solid, the process known as solidification. Similarly, on increasing temperature of a liquid, it can be changed into a gas, a process known as vaporization. A gas can be changed back to a liquid by decreasing temperature, a process known as condensation. A solid can directly change to a gas without converting into a liquid, a process known as sublimation. The gas can get back to its solid state, and a process known as sublimation or deposition.